This is a sun. The sun is a star located in the very center of our solar system, responsible for many things. Its diameter is about 1.39 million kilometers, or 330,000 times that of Earth. The sun is so big, its mass accounts for about 99.86% of the total mass in the solar system. It's composed around 73.5% of hydrogen, 84.85% of helium, 0.77% of oxygen, and the rest are materials such as carbo, iron, neon or nitrogen. Now, there are many stars located in our universe. Let's go on a tour to demonstrate the sizes of a few stars. Quite the giant he is. The Uyscuti is currently the largest observable star known to mankind. Its radius is about 1.2 billion kilometers or 7.9 astronomical units. Its density is 5 billion times larger than the sun's. The star is located about 9,500 light years away from Earth. If it was in our solar system, it would go way past Jupiter's orbit. In the meantime, here's a simulation of what it would look like. For your information, the sun's luminosity is about 1 luminosity unit, while Scuti's is about 340,000. I've decided to experiment on various things in our system. For example, here, what would happen if we cut the sun's mass by half? The results are quite catastrophic. Since I basically reduced the sun's mass from 1 sun mass to near 0.5 sun masses, the gas giant's stranded way further from the sun. No more Saturn. No Uranus. No Neptune. And no Jupiter. Things aren't so bad for Mercury though. It created a new orbit around the sun and now lives in the new habitable zone. Go figure. It is quite mandatory to understand the importance of the habitable zone. If the sun doubled in mass this time, we'd be way out. In short, everyone dies. Anyways, the reason almost every planet would leave orbit if the sun lost half its mass, is because such heavy planets can't be retained by the small sun. It's how gravity works. The planets would want to leave but the sun tugs them in, therefore creating an orbit. Onto the topic of supernovas. A supernova is basically the death of a star. It's a quite violent explosion. In order for a star to go supernova, it has to have a mass greater than at least 8 solar masses. Here is a simulation of a custom star going supernova after expiring. This is known as a Type II supernova, where an object much bigger than the sun runs out of hydrogen and helium at the core. Here's what happens next. Supernovas can travel quite the distance. The last supernova visible to the eye was documented by Johannes Kepler in 1604, at about 20,000 light years. However, let's say, if a supernova happened 30 light years away from Earth, we'd still face extinction. The pure power will be enough to destroy most of our ozone layer and end us. This may happen after a so-called stellar collision. For example, let's throw the sun directly into the sun. The sun's insane gravitational pull simply bonded with the pull of its copy, colliding and creating a massive supernova. What is left after such an event is called a supernova remnant. In either case, the resulting supernova explosion expels much or all of the stellar material with velocities as much as 10% the speed of light, or approximately 30,000 km/s. Now, let's get into the bigger scale. A fun thing I wanted to tell you about galaxy collisions. This process can take up to several hundreds of millions of years, and can sometimes lead to galaxy merging. Both star constellations mix, creating an even bigger galaxy. This most commonly happens with spiral galaxies.